According to the National Electrical Code, dwelling unit bedrooms require either 15 or 20 amp circuits protected by a circuit breaker or fuse. This is stated in NEC 210.11. C4. Bedrooms also require arc fault circuit interrupters, or AFCIs, for all 15 and 20 amp branch circuits that supply luminaires, receptacles, or both. This requirement is detailed in NEC 210.12. A. Therefore, installing 10 amp breakers on bedroom circuits in place of AFCIs is not in compliance with the NEC. There are several reasons why 10 amp breakers should not be installed in place of AFCIs. Firstly, AFCIs are specifically designed to detect and interrupt dangerous arcing faults. These faults can occur on any circuit, irrespective of its amperage. Secondly, 10 amp breakers do not provide the same level of protection as AFCIs. They may not trip quickly enough to prevent an electrical fire. Thirdly, installing 10 amp breakers in this situation is a direct violation of the NEC. Authorities having jurisdiction or ODGs should not allow this practice. In conclusion, installing 10 amp breakers on bedroom circuits in place of AFCIs is incorrect and potentially dangerous. It violates the NEC and compromises electrical safety. AFCIs are essential for protecting bedrooms from electrical fires and should always be used as required by the code. The role of an arc fault circuit interrupter is to provide protection from fires resulting from electrical arcs. An arc is an unintentional electrical discharge between two or more conductors. Arcing can generate very high temperatures exceeding thousands of degrees Fahrenheit, which can ignite nearby materials, leading to a fire. AFCIs are designed to detect these dangerous arcing conditions and quickly interrupt the circuit, preventing a fire. There are two main types of AFCIs: branch/feeder AFCIs and outlet branch circuit AFCIs. Branch/feeder AFCIs are installed in the panel board and provide protection for the entire branch circuit. Outlet branch circuit AFCIs are installed at the first outlet on the branch circuit and provide protection for the remainder of the circuit downstream. The National Electrical Code specifies where AFCIs are required in dwelling units. Some common locations include bedrooms, living rooms, dining rooms, family rooms, parlors, libraries, dens, sunrooms, recreation rooms, closets, hallways, and similar rooms or areas. The specific requirements may vary depending on the edition of the NEC being used and local amendments. AFCIs work by monitoring the electrical waveform for characteristics that are indicative of arcing. These characteristics include erratic current flow, high-frequency noise, and voltage drops. When an AFCI detects these characteristics, it trips the circuit, interrupting the flow of electricity and preventing a fire. The trip time of an AFCI is very fast, typically in the range of milliseconds. This rapid response time is crucial for preventing fires, as arcing faults can quickly escalate into dangerous situations. Standard circuit breakers are designed to protect against overloads and short circuits. Overloads occur when the circuit is carrying more current than it is designed to handle, while short circuits occur when there is a low resistance path between two conductors. While circuit breakers can provide some protection against arcing faults, they are not specifically designed for this purpose and may not trip quickly enough to prevent a fire. This is why AFCIs are required in addition to circuit breakers in many locations. The NEC requires that AFCIs be readily accessible. This means that they should be located in a place where they can be easily inspected and tested. AFCIs should also be tested periodically to ensure that they are functioning properly. The manufacturer's instructions typically provide guidance on how to test an AFCI. When selecting an AFCI, it is important to choose one that is listed by a recognized testing laboratory, such as Underwriters Laboratories, or UL. This listing indicates that the AFCI has been tested and meets certain safety standards. It is also important to select an AFCI that is compatible with the electrical system in which it will be installed. The voltage, amperage, and wiring configuration of the AFCI must match the electrical system. Proper installation of AFCIs is crucial for ensuring their effectiveness. AFCIs should be installed by a qualified electrician who is familiar with the NEC requirements and the manufacturer's instructions. The electrician should also test the AFCI after installation to ensure that it is functioning properly. There are some common misconceptions about AFCIs. One misconception is that AFCIs are not necessary if the electrical system is properly grounded. While grounding is an important safety measure, it does not provide protection against arcing faults. Another misconception is that AFCIs are only required in new construction. While the NEC has expanded the requirements for AFCIs over time, they are now required in many existing homes as well. It is important to stay up to date on the latest NEC requirements and local amendments to ensure that your electrical system is safe. If you are unsure whether your electrical system meets the NEC requirements for AFCIs, it is best to consult with a qualified electrician. They can inspect your electrical system and recommend any necessary upgrades. The cost of installing AFCIs can vary depending on the number of AFCIs being installed, the complexity of the electrical system, and the local labor rates. However, the cost of installing AFCIs is relatively small compared to the potential cost of a fire. In addition to AFCIs, there are other safety devices that can help protect against electrical hazards. These include ground fault circuit interrupters, or GFCIs, surge protectors, and smoke detectors. GFCIs are designed to protect against electric shock, while surge protectors are designed to protect against voltage spikes. Smoke detectors are designed to detect fires and alert occupants to the danger. It is important to have a comprehensive safety plan in place to protect against all types of electrical hazards. This plan should include regular inspections of the electrical system, proper maintenance of electrical equipment, and the use of appropriate safety devices. Electrical safety is a shared responsibility. Everyone should be aware of the potential hazards of electricity and take steps to protect themselves and others. This includes following safe practices when using electrical appliances, avoiding contact with exposed wires, and reporting any electrical hazards to a qualified electrician. The NEC is a comprehensive set of standards for electrical safety. It is updated every 3 years to reflect the latest advances in technology and safety practices. The NEC is adopted by many states and local jurisdictions, and it serves as the basis for electrical codes across the country. It is important for electricians and other electrical professionals to stay up to date on the latest NEC requirements to ensure that they are providing safe and reliable electrical installations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as dwelling units, commercial buildings, and industrial facilities. The NEC is a complex document, and it can be challenging to understand all of the requirements. However, there are many resources available to help electricians and other electrical professionals stay up to date on the latest codes and standards. These resources include training courses, seminars, and online publications. The NEC is an essential tool for ensuring electrical safety. By following the NEC requirements, electricians and other electrical professionals can help protect people and property from electrical hazards. The NEC is not a static document. It is constantly evolving to reflect the latest advances in technology and safety practices. This means that it is important for electricians and other electrical professionals to stay up to date on the latest changes to the NEC. The NEC is developed by the National Fire Protection Association, or NFPA. The NFPA is a non-profit organization that develops codes and standards for a wide range of hazards, including fire, electrical, and life safety. The NFPA has a long history of developing codes and standards, dating back to 1896. The NFPA's codes and standards are used by governments, businesses, and individuals around the world. The NFPA is committed to reducing the risk of fire and other hazards. The NFPA's mission is to help save lives and reduce property loss. The NFPA is a valuable resource for anyone who is interested in electrical safety. The NFPA's website contains a wealth of information on electrical codes, standards, and safety practices. The NFPA also offers training courses and seminars on electrical safety. Electrical safety is a critical issue. By following the NEC requirements and taking other safety precautions, we can all help protect ourselves and others from electrical hazards. The NEC is a living document that is constantly being updated to reflect the latest advances in technology and safety practices. It is important for electricians and other electrical professionals to stay up to date on the latest changes to the NEC to ensure that they are providing safe and reliable electrical installations. The NEC is a complex document, but it is essential for ensuring electrical safety. The NEC is a valuable resource for anyone who is interested in electrical safety. By following the NEC requirements and taking other safety precautions, we can all help protect ourselves and others from electrical hazards. The use of 10 amp breakers when the code specifies 15 or 20 amp breakers presents a significant safety concern. The purpose of a circuit breaker is to protect the circuit and its connected devices from overcurrent conditions, which can lead to overheating and potentially fires. When a 10 amp breaker is installed on a circuit that is designed for a higher amperage, such as 15 or 20 amps, the breaker may not trip quickly enough or at all under overload conditions. This can allow the circuit to become overloaded, causing the wires to overheat and potentially ignite nearby materials. Furthermore, the use of undersized breakers can also mask underlying problems with the electrical system. If a circuit is constantly tripping a 10 amp breaker, it may be an indication that there is a short circuit, ground fault, or other issue that needs to be addressed. Simply replacing the breaker with a larger one will not solve the problem and may actually make it worse by allowing the circuit to become overloaded and potentially causing a fire. In addition to the safety concerns, the use of 10 amp breakers in place of 15 or 20 amp breakers is also a violation of the National Electrical Code. The NEC specifies the minimum size of conductors and overcurrent protection devices that are required for different types of circuits. The NEC is a legally enforceable document in many jurisdictions, and violations can result in fines, penalties, and even criminal charges. It is important for electricians and other electrical professionals to follow the NEC requirements to ensure that electrical installations are safe and compliant. The authority having jurisdiction, or OJ, is responsible for enforcing the NEC and other electrical codes in a particular jurisdiction. The AHA may be a local building inspector, fire marshal, or other official. The AHA has the authority to inspect electrical installations, issue permits, and order corrective action if violations are found. It is important to work with the AHA to ensure that electrical installations are compliant with all applicable codes and regulations. The use of arc fault circuit interrupters, or AFCIs, is another important safety requirement in dwelling units. AFCIs are designed to detect and interrupt arcing faults, which are a common cause of electrical fires. Arcing faults can occur when there is a loose connection, damaged wire, or other condition that causes electricity to jump between conductors. The resulting arc can generate very high temperatures, which can ignite nearby materials and cause a fire. AFCIs are required in many locations in dwelling units, including bedrooms, living rooms, dining rooms, and other areas where arcing faults are likely to occur. AFCIs are an effective way to prevent electrical fires and protect occupants from harm. In addition to AFCIs, ground fault circuit interrupters, or GFCIs, are also required in many locations in dwelling units. GFCIs are designed to protect against electric shock. Electric shock can occur when a person comes into contact with a live electrical conductor. The resulting current flow can cause serious injury or death. GFCIs are required in bathrooms, kitchens, and other areas where there is a risk of electric shock. GFCIs work by monitoring the current flow in a circuit. If the current flow is not balanced, it indicates that there is a ground fault, which means that electricity is flowing through an unintended path, such as a person's body. While a GFCI detects a ground fault, it quickly interrupts the circuit, preventing electric shock. GFCIs are an effective way to protect against electric shock and save lives. The NEC requires that all electrical work be performed by qualified electricians. Qualified electricians have the training, experience, and knowledge necessary to perform electrical work safely and correctly. They are also familiar with the NEC and other electrical codes. It is important to hire a qualified electrician to perform any electrical work in your home or business. This will help ensure that the work is done safely and correctly and that the electrical system is compliant with all applicable codes and regulations. Electrical safety is a shared responsibility. Everyone should be aware of the potential hazards of electricity and take steps to protect themselves and others. This includes following safe practices when using electrical appliances, avoiding contact with exposed wires, and reporting any electrical hazards to a qualified electrician. By working together, we can all help to prevent electrical accidents and injuries. The dangers associated with circumventing electrical codes are significant and far-reaching. Electrical codes, such as the National Electrical Code, are established to ensure the safety of people and property. These codes are developed by experts in the field of electrical engineering and safety, and they are based on years of research and experience. When electrical codes are circumvented, the risk of electrical fires, shocks, and other hazards increases dramatically. Electrical fires are a leading cause of property damage and injuries in the United States. According to the National Fire Protection Association, electrical fires cause billions of dollars in property damage each year and result in hundreds of deaths and injuries. Electrical fires can be caused by a variety of factors, including faulty wiring, overloaded circuits, and misuse of electrical appliances. When electrical codes are circumvented, the risk of electrical fires increases significantly. Electrical shocks can also be very dangerous, and they can even be fatal. Electrical shocks can occur when a person comes into contact with a live electrical conductor. The severity of the shock depends on the amount of current that flows through the body, the path of the current, and the duration of the contact. Electrical shocks can cause burns, muscle spasms, cardiac arrest, and other serious injuries. When electrical codes are circumvented, the risk of electrical shocks increases significantly. In addition to the immediate dangers of electrical fires and shocks, there are also long-term consequences of circumventing electrical codes. For example, improperly installed wiring can lead to premature failure of electrical components, which can result in costly repairs. Furthermore, homes with electrical code violations may be difficult to sell, and they may not be insurable. It is important to note that electrical codes are not just arbitrary rules. They are based on sound engineering principles and safety considerations. When electrical codes are followed, electrical systems are much safer and more reliable. When electrical codes are circumvented, the risk of electrical fires, shocks, and other hazards increases dramatically. Therefore, it is essential to always follow electrical codes and to hire qualified electricians to perform all electrical work. The role of qualified electricians in upholding electrical safety cannot be overstated. These professionals undergo extensive training and education to understand the intricacies of electrical systems and the potential hazards associated with them. Their expertise is crucial in ensuring that electrical installations are safe, compliant with codes, and function reliably. Qualified electricians possess a deep understanding of electrical theory, wiring methods, and safety procedures. They are trained to identify potential hazards, such as overloaded circuits, faulty wiring, and improper grounding. They also know how to properly install and maintain electrical equipment to minimize the risk of accidents. Moreover, qualified electricians are familiar with the National Electrical Code and other relevant standards. They understand the requirements for different types of electrical installations and ensure that all work is performed in accordance with these codes. This compliance is essential for preventing electrical fires, shocks, and other hazards. In addition to their technical skills, qualified electricians also possess important problem-solving abilities. They can diagnose electrical problems, troubleshoot malfunctions, and develop effective solutions. Their expertise is invaluable in ensuring that electrical systems operate safely and efficiently. Furthermore, qualified electricians play a crucial role in educating homeowners and business owners about electrical safety. They can provide advice on how to use electrical appliances safely, how to identify potential hazards, and how to respond in the event of an electrical emergency. Their guidance can help prevent accidents and save lives. When hiring an electrician, it is essential to ensure that they are properly licensed and insured. Licensing requirements vary by jurisdiction, but they typically involve passing an examination and completing a certain amount of training. Insurance provides protection in case of accidents or damage caused by the electrician's work. By hiring a qualified and reputable electrician, homeowners and business owners can have peace of mind knowing that their electrical systems are in safe hands. The NEC serves as the cornerstone of electrical safety in the United States. This comprehensive document outlines the minimum standards for electrical installations, ensuring that electrical systems are designed, installed, and maintained in a safe and reliable manner. The NEC is developed by the National Fire Protection Association through a consensus-based process that involves experts from various fields, including electrical engineering, safety, and manufacturing. This collaborative approach ensures that the code reflects the latest knowledge and best practices in the electrical industry. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as dwelling units, commercial buildings, and industrial facilities. The code is organized into chapters, articles, and sections, making it easy to navigate and find the information needed for a particular electrical installation. The NEC is updated every 3 years to reflect advances in technology and changes in safety practices. These updates are essential for ensuring that the code remains relevant and effective in protecting people and property from electrical hazards. The NEC is adopted by many states and local jurisdictions, and it is legally enforceable. This means that electrical contractors and other professionals must comply with the code when performing electrical work. Failure to comply with the NEC can result in fines, penalties, and even legal action. The NEC is not intended to be a design manual. It provides the minimum requirements for electrical safety, but it does not provide detailed guidance on how to design an electrical system. Electrical engineers and other qualified professionals are responsible for designing electrical systems that meet the specific needs of a building or facility. The NEC is a valuable resource for anyone involved in the electrical industry. It provides a comprehensive set of standards for electrical safety, and it is essential for ensuring that electrical systems are safe and reliable. The NEC is available for purchase from the National Fire Protection Association and other sources. It is also available online through various subscription services. The NEC is a complex document, but it is essential for anyone who works with electricity. By understanding and following the NEC requirements, electrical professionals can help protect people and property from electrical hazards. The ongoing debate surrounding code interpretations and enforcement highlights the complexities of ensuring electrical safety. While the National Electrical Code provides a comprehensive set of standards, its interpretation and enforcement can vary depending on the jurisdiction and the individuals involved. This variability can lead to confusion, inconsistencies, and even disputes. Code interpretations can be subjective, and different individuals may have different understandings of the same code requirement. This is especially true for complex or ambiguous code sections. To address this issue, many jurisdictions have established procedures for resolving code interpretation disputes. These procedures typically involve consulting with experts, reviewing relevant documentation, and making a final determination based on the available evidence. Code enforcement is the process of ensuring that electrical installations comply with the NEC and other applicable codes. This process is typically carried out by local building inspectors or other officials. Code enforcement can be challenging as it requires inspectors to have a thorough understanding of the code and the ability to identify violations. To improve code enforcement, many jurisdictions have implemented training programs for inspectors. These programs provide inspectors with the knowledge and skills they need to effectively enforce the code. Despite these efforts, code enforcement is not always consistent. Some jurisdictions may have more stringent enforcement practices than others. This inconsistency can lead to unfairness and can undermine the effectiveness of the code. To address this issue, some organizations have proposed establishing national standards for code enforcement. These standards would help ensure that the code is enforced consistently across all jurisdictions. The debate surrounding code interpretations and enforcement is ongoing. However, It is clear that these issues are critical to ensuring electrical safety. By working to improve code interpretations and enforcement, we can help protect people and property from electrical hazards.